So I'm here today with Udi Dahan, CEO of Particular Software and world-renowned speaker and blogger, and far more than that. Also the creator of NServiceBus, a service bus, obviously, for the .NET platform, which allows a lot of different architectural patterns to be baked into your software quickly and easily, managing your workflow through your messaging system, whatever that messaging system backend may be. Udi, it's a wonderful pleasure to have you here. I really appreciate you taking the time to be here. So thank you very much for doing this.
Well, thank you for having me, Derek. It's my pleasure.
So today I would like to discuss really the particulars of service buses, what those really are, what a service bus is, where the idea came from, and how a service bus can really help us with messaging software and messaging patterns and help us be more productive in these systems that we are creating across multiple physical machines and other boundaries. But before we get into that, I'd like to take a step back and ask you a few questions about how you got started with messaging software. I recently interviewed Jimmy Bogard, who said that you've been doing messaging software since possibly the early 2000s or late 1990s. So, how
Yeah.
did you get into messaging software back then, and what were you using back then?
So the first use I had was a very large distributed system that was built for the Israeli Air Force.
Oh, wow. Okay.
It was built in a very old language called Ada.
Ada.
Um,
Wow.
yeah,
Named after Ada
um,
Lovelace, of course.
that's right. And it was the kind of system where when they say mission critical, it actually means the literal term mission
Mission
critical.
critical.
It
Wow.
gets bandied about fairly
It's,
frequently in commercial types of settings,
yep.
but there it really meant it.
Wow.
And the whole system was built on this paradigm of mailboxes. Everything would be done by putting a message in a mailbox.
Okay.
And that was sort of the first really large scale project that I was on.
Hmm.
And I was just one developer out of a team of I don't know how many hundreds even.
Wow.
So it was just kind of like, this is the way that we do it. I'm like, okay,
Okay. That's
sure. What do I know?
right.
So kind of went with the flow. The language wasn't that great, but just that style of programming, it for me doing the actual development work, it was fairly simple
Hmm.
in terms of the amount of complexity that I needed to keep in my head at any time,
Right.
because each bit was almost always triggered by a message coming in off of one mailbox. You do a little bit of work and then you put messages in other mailboxes.
Hmm.
And that was kind of how everything was built. And they had this really crappy interface definition language thing. It wasn't
Right.
that pleasurable to use. Ultimately, everything needed to be coded down to really tight binary format. But this concept of having strict message contracts and contract definition and evolution and keeping things decoupled was right there from the very beginning.
Hmm.
And I got to see that system go live and see it working in let's call it really difficult types of production environments.
Right.
It's not the kind of thing where everything's just running in a single data center,
Right.
but being able to deal with connectivity issues and seeing the system recover automatically from that.
Hmm.
So that was my earliest experience of large-scale systems development
Right.
that just happened to have this concept of messaging in there. And I somewhat took it for granted. I mean, this is
Yeah.
how
Yeah.
you do large-scale systems development. And then when I went out into the commercial world and I saw that that wasn't the case, I was like, wait a minute, why aren't you doing this? I mean, you're using much more advanced programming languages than
Hmm.
what I had used, but why don't you have this thing? Why is everybody doing RPC type of communication, the synchronous request response?
Yep.
Because that was a big no-no. I said, don't even think about doing that. Don't try to do that on top of the mailboxes, because it's just going to cause the system all sorts of grief.
Yeah, there's going to be connectivity failures and parts of the system going down. You're not going to have guarantee of everything being there. So I
Right.
can definitely see how the RPC world is kind of counter to the idea of the mailboxes that you had previously worked with.
Right. So that was the start of it for me, and then moving into .NET, and doing projects there. It's like, oh, okay, you know, I looked for the thing
Hmm.
that was closest to the message box, and I said, oh, okay, there's this MSMQ thing,
Right.
uh, which, MSMQ was not a great technology, but
Yeah, but it works.
well, around the time the .NET was released, 2001,
Hmm.
2002, MSMQ was still not that great. It only got better at around 2003,
Okay.
when I think it was SP1 of Windows XP or something like that on the
Right.
client, and then you got Windows 2003 server. Then it kind of got quite a bit more robust.
Right.
But at the time, I was using a lot of Tibco Rendezvous, and
Okay.
Rendezvous was an absolutely amazing, first of all, very low latency, very high performance messaging platform.
Very nice.
There, the .NET APIs were, left something to be desired, but that's how I got started in it. It was just that this sort of early experience that
Hmm.
this thing really works under the most strenuous of circumstances.
Hmm.
And all of the other available technologies at the time that for the vast majority were, communicating over HTTP or TCP, whether you're talking about XML web services or .NET
Hmm.
remoting or Java RMI or, all of those various equivalents, the synchronous request response style, every time I was brought into a project that was doing that, I would say, but wait a minute, how's the system going to work when, that process dies?
Yep.
And people kind of looked at me funny
What do you
for
mean?
even asking that question. Why
Yeah.
would that ever happen? And I'm like, here, I just kill the process and you see how the rest of the system hangs. They're like, oh yeah, that's not our problem. And it was just a weird concept for me.
Right.
How is that not your problem? But at the time, there wasn't this sort of big DevOps type movement.
Right.
Developers just focused on writing the code, and works on my machine was actually a reasonable statement to be made
I remember those days.
when checking in code or throwing it over to QA.
Yep.
So I wasn't coming from that background, but that's kind of how I got started and why I felt like something needed to be done to lower the barrier of
Right.
entry for other
Right.
people.
So was that the kind of the genesis of NServiceBus right there? Was that desire to lower the barrier of entry for people to do message-oriented systems like that?
Well, so at the time I was working at a consulting company, and the people that I was trying to lower the barrier for were the other developers on the team.
Okay.
I didn't think that they needed to be experts in Tibco or MSMQ or anything else
Right.
like that. Just wanted to have a nice, simple abstraction on
Mm-hmm.
top of that underlying technology so that they could publish events and send commands and handle messages coming in.
Right.
And that most of the yucky, low-level concerns about managing connections and all sorts of options on the message and time to live. And
Mm-hmm.
there's a million and one little options down there
Mm-hmm.
that the average developer that wants to write some business logic shouldn't have to deal with.
Mm-hmm.
So it was just kind of taking a lot of the abilities that were in the libraries and just creating an abstraction layer on top of that. That's how it got started.
Okay.
And after one project to the next, that abstraction layer kind of got bigger and more fully featured to the point where I was like, okay, it's a thing in its own right.
Right. Right.
But at the time, I didn't really think that anybody would need to have like a standardized wrapper around a
Right.
queuing system.
Right.
But after a number of years of working with dozens of developers on various projects, just saw that there's actually a whole bunch of complexity.
Yep.
And there's a million ways of setting things up that, for let's say 99% of the business systems that are out there, they should all work a certain way.
Hmm.
So yes, for the 1% that really needs to do something special in every single case, fine, they can drop down to the lowest layer. But
Hmm.
really, everybody else should just use a very strong abstraction around the whole concept of a queuing system.
Yeah, and I think my own personal experiences very much mirrors what you just said. I started with WebSphere MQ and my own abstraction layer on top of that in .NET back in 2008, 2009 timeframe. And I had looked at NServiceBus as an abstraction layer to use. I had also looked at mass transit at the time, and honestly said to myself, oh, I don't need these big layers of abstraction and these extra systems. I'm just going to go straight to the message queue.
Mm,
Well, a year later, I had my own poorly specified, half implemented, terrible version of a service bus and
right.
realized, when it was too late, I really should have just stuck within service bus because I've baked half of the patterns that you had into my abstraction, and it is very poorly specified and significantly less flexible at this point. So
Well, that's
I
the thing,
it's
nobody realizes that they need one. I mean, there's
right.
this, how hard could it be? I think
Yeah,
that's
exactly.
you
It's
know,
just a message. I'm just putting it here and then I'm getting it and how hard could it be?
right.
It's
And WebSphere or TIBCO or those
yeah.
types of technologies that have a great deal of power,
Yeah.
there is a great deal of complexity down there. And the answer to how
It's
hard can it be is pretty damn
pretty
hard.
damn hard. WebSphere
Uh,
especially, there we spent tens of thousands of dollars on training for WebSphere and we still pulled our hair out constantly fighting that.
right.
But we made it work, and it was a similar situation to where you started. I was working on a system for the U.S. military. It was
Yeah.
their ground-based maintenance system, so it certainly wasn't mission critical like yours was, but it was still loss of connectivity, systems going down, and that's where we got the idea, oh, let's use a messaging system so that we can reconnect things and have messages pushed across when the connection is available. And ultimately, it did work out really well for that project. We were quite happy with it. And that was my first foray into messaging. So we've mentioned service buses a number of times here, and service bus in particular, and the half-baked one that I had built back in those days. But I want to step back again and ask, what is a service bus? What is the real value that the service bus is going to add other than just being an abstraction layer on top of your messaging system?
Right. So the first issue is that the term service bus is itself quite overloaded.
Okay.
When service-oriented architecture started to take off in
Mm-hmm.
around 2005, 2006, that's when a lot of the vendors, your IBM, your Web Methods, your
Right.
Oracles of the world, that they had pre-existing message broker technology,
Right.
and that they'd built for the most part in the early 90s and kind of continued evolving it since then. And
Mm-hmm.
when the industry said, "Oh no, we don't want message brokers anymore. Brokers are passé. They're out.
It's
We want this new service-oriented bussy thing
mm-hmm.
that'll be distributed and scalable and all these nice things." Then the big vendors kind of turned around, repackaged a lot of their existing technologies, and to a large extent, they web servicized them. They
Right.
said, you don't want message brokers? Fine. They now speak WSDL. They
Right.
now support all sorts of other specs from the WS star. The security, the transaction, the addressing, the reliability, and of course, you have orchestration and content-based routing and all of these other kind of feature sets.
Mm-hmm.
So let's call it, that's the enterprise service bus. That's where the
Okay.
enterprisey bit is coming
Right.
in. So what you'll invariably see with a lot of enterprise service bus technologies is that there's a very strong focus on web services and enabling RPC, synchronous request response type work,
Okay.
for the average .NET developer, the technology that would be most similar to this would be like a BizTalk.
Right.
So kind of a big monolith in the middle that you kind of drag and drop all sorts of orchestrations and transformations inside of, and everything connects to it and it connects to everything else.
Okay.
That's the one
Right.
category.
That's the big enterprise service bus.
Right. Now, where NServiceBus and mass transit and a lot of the other offshoots came from was actually the no, we don't actually like web services in this
Hmm.
request response style. We're not trying to support that or to make that easy or to promote that as a common integration philosophy.
Hmm.
We want to build the heart of our system around a different set of concepts. So I'd say to some extent it was very microservice oriented to
Okay.
begin with because the idea around NServiceBus was how do I build a system, a single system, on top of this in a loosely coupled way so that there are lots of separate parts,
Hmm.
rather than the enterprise service bus perspective of how do I integrate a bunch of distinct and in many cases already existing
Mm.
systems that are already out there. So that's what I'd say the N-service bus and the modern incarnations of microservice type technology are coming from. It's the perspective of how do we build a system the right way, as
Hmm.
opposed to how do we integrate a bunch of
Existing
existing systems.
systems. Right.
Right. So I'd say that's the number one difference.
Right.
And it's very confusing because
It's,
the terms are just so similar.
yeah.
Uh,
Just add that little enterprise in front of service bus, and suddenly you have a completely different ball game that you're talking about.
right, right.
Right.
So back to your question from before. Maybe you can remind me as well as our listeners what the original question was.
Sure. So I wanted to get at what the heart of a service bus is, like N-Service Bus or mass transit, or
Mhm,
even my own more recent working with my own Node.js library that I called Rabus. I'm kind of
mhm,
heading down the path of a service bus with that, with some changes I made recently, and I want
mhm.
our listeners to really get a sense of the value and the features and capabilities that a service bus should provide on top of their messaging system in whatever
Mhm.
language they happen to be using.
Right. So I'd say that there are a couple of levels to a service bus. There's the first one, which is let's call it common messaging best practices
Hmm.
type of area, where, for example, let's say you want to do a request response messaging pattern.
Right.
Then, in order for that to work, because it's not synchronous necessarily, you could have a single client interacting with a server along three conversations in parallel because
Hmm.
everything's async by default. So then you need a way for the client to know which response is associated with which request that they sent
Right.
because everything's happening in parallel.
Right.
So then you have really simple things like making sure that every response message includes a header on it with a correlation ID, which is the message ID of the original request that came out,
Right.
and to probably provide a higher level API at the client side for being able to implement like a callback style
Right.
model. So I'd say that that's sort of the first layer of stuff that you'll see in almost every service bus. It's just kind of making the messaging patterns easier to consume by a developer.
Right.
Okay.
So in the case of the Wascally library, which is my preferred abstraction on top of RabbitMQ, there is a request method and you get a response directly from that. And it uses a combination of correlation ID behind the scenes.
Right.
Nobody other than the Wascally library ever knows about this correlation ID, but it allows you to very easily just say, oh, I need to request this information, and it's a message, by the way. And then something else on the other end sends a reply back through a RabbitMQ private queue or exclusive
Mhm.
queue. So in the case of RabbitMQ, a correlation ID is used slightly differently than in other queuing systems, but it's still there, and we get that reply coming back. And then Wascally, that library, manages understanding which response goes with which request so that the developer doesn't have to deal with that.
Right. And you bring up another point, which is very important, is also the management of the topology.
Right.
So which queues are we going to be using for what to make sure that messages go where they need to go, that they get consumed the right number of times. So if it's a request or a response, it should really be only consumed once.
Right.
However, if it's an event, then we fully expect it to be consumed multiple times. And there are different ways of setting that up, whether you're using RabbitMQ or MSMQ or Azure Service Bus or whatever type of queuing technology.
Right.
Just making sure that the higher level expectations of a developer when they're saying, I want to publish to an event or I want to subscribe to an event, that all of that routing is just taken care of behind the scenes with all of the necessary headers and metadata, so that they can focus on the business problem, and that this lower level will just make sure that it's kind of the make it so library.
Right.
Can I just have it work? That's what it's there for.
Make it so number one.
Exactly. So that's the first bit.
Right.
The second bit is when you start getting into, let's call it, more production readiness types of scenarios, where you start dealing with things like the intersection between the business logic that's processing a message and the queuing system together. So let's say that as a part of processing a message, you try to talk to a database and you get, I don't know, exception that's thrown like connection refused by the remote host. The database connection pool is maxed out or something.
Right.
Now, again, you as a developer can write the code yourself to say, oh, okay, I got that. I'm going to catch that exception. I'm going to wait a couple of milliseconds, and then I'm going to retry connecting to the database and do that again.
Right.
And in essence, you can roll your own retry type logic. But then you find that you end up creating your own type of infrastructure library for business message processing, retrying stuff.
Yeah, I'll just add a timeout, set timeout in my Node.js code here, and I'll just retry it again, and then you end up with memory exploding because you have thousands of messages that are in these set timeouts and all kinds of potential problems there.
So that's the next bit of kind of implementing that type of exception handling, retry logic, dealing with poison messages. So let's say a message couldn't be deserialized, then moving that somewhere. So there's a whole other set of taking a message-driven system and making it fit for production.
Right.
That usually a developer, when they're starting a project, they don't actually see the need for it. But once they deploy the system to production and start dealing with these situations, especially if you're talking about deploying version 2, version 3 of a system, where you start having these types of version incompatibilities, that you start having to solve these problems, then you're like, okay, so where I'm going to write the exceptions to, and then how do I centralize them, because I have all of these distributed machines, and you create a whole other set of capabilities to get your message-driven system ready.
Right.
So you'll see those types of things in a service bus technology. So the just handling the exceptions and the rolling back and the retrying and the timeouts and the poison message handling and preferably centralizing all of that information and creating some sort of UI that allows an administrator to be able to see that there's a problem in a system and then to send a message to be processed again once it's been resolved. There's a whole other set of functionality that, again, people don't know that they need until they start building it. And then they realize, oh my God, this rabbit hole goes really, really deep.
Really deep. That's exactly what I ran into in that first project back in 2008, 2009. I started running into message size limitations. We were dealing with XML, which is a very verbose format, and we were running into, it was 100K limit, I think, was the default message size for WebsterMQ at the time. It was
Mm,
either 100K or 1 meg, whatever it
mm,
was. We were sending ridiculously large messages, several megs in size. So we had to go in and essentially build middleware into our stack that allowed us to take a single message, split it apart into multiple pieces that were numbered so that we knew how many total messages there were and which message number this was, send them all across the system, wait for all of the messages to be collected on the other side, repiece it together, and then be able to process it by the actual business logic.
right.
So it's those kinds of rabbit holes that a service bus will really help somebody solve. And I ran into a similar problem where I needed some middleware recently in my project where I have messages that were getting out of order, and that was showing up in the user interface because there was a status of these three things in the user interface that said they were still running, when in reality they had already completed and things that depended on those had already kicked off.
Right.
So the user interface was out of sync with the actual in memory representation. The messages were out of order. The older messages were getting applied to the database save and showing things incorrectly. So again, I built some middleware into my Rabbis library that allowed me to just reject old messages. I keep track of the sequence of messages being sent. If it's an old message, you're canned. If it's a future message beyond where I currently am, I don't care. I'm just going to
Mm,
apply that future message because it contains the full document in my case. So there's so many
right.
different rabbit holes that you can go
Mm,
down, so many different problems that you can run into, exception handling especially, retrying messages. There's a million different things that you need to keep track of that a service bus, a proper good implementation will hopefully help you be able to not have to deal with those things.
right. Right.
So where do we go beyond a service bus though? Is that kind of the end game for the business layer abstractions, or is there something that we do beyond end service bus or mass transit or whatever it is that we're using?
So there are certain, let's call it, opinions
Okay.
in service bus that we enforce that move it beyond the element of being, let's call it, technological to being architectural.
Hmm.
So one of the opinions in there is that only a given logical endpoint can publish a given event type.
Okay.
So for each event type, you could have one logical publisher. And I can
Hmm.
scale out that publisher to multiple physical nodes, but you only get one of them. And when people run into that the first time, they kind of say, but wait, how how exactly am I going to make that work for me? Because what I wanted to do is I wanted to publish a create customer command,
Right.
and then I'll have this auditing listener that's going to listen to all of the messages coming through, and that's how I'll do my audit.
Hmm.
Like, okay. So you want auditing.
Hmm.
The right way to do auditing is actually differently.
Okay.
So auditing is something that should be done from the perspective of when an endpoint processes a message, and only after that message processing was successful,
Hmm.
do you want to actually audit that. So you don't actually want to split up a command to multiple queues because the queuing system and all of the previous layers that we talked about will guarantee that that message won't be lost.
Hmm.
So it's always going to be somewhere. And only after it's done processing, then we'll have another piece of infrastructure that's going to go audit that. And if you want to extend the auditing functionality, well, there's a different part of the stack that you extend.
Okay.
But you can't go publishing commands, for example. It'll say no. That just it won't let you do that. And if you try to have multiple publishers of the same event, because you're saying I want to publish an audit here and I want to publish an audit there, I say no, wait a
Right.
minute. Your architecture, you're mixing up logical and physical concerns.
Hmm.
And I'd say that that's probably one of the most common problems that people run into when going to design a message-driven system
Right.
is they don't realize that there are actually two levels of work that you need to be thinking about, the logical and the physical. And what the service bus, or what we try to do in NServiceBus, is we try to make it so that you're modeling at the logical level according to certain rules.
Hmm.
And when you do that, that will guide your solution to fulfilling things like the single responsibility principle the
Hmm.
right way. And thus you will have highly cohesive, loosely coupled parts of your system that if you change something over here, it's not going to end up breaking things all over the place.
Right.
So I'd say that's the part where we start getting into an architecturally significant piece of technology
Mm.
because it's not just a library, it's not just a framework that says, okay, this
Hmm.
is, you have to conform to these APIs. It goes a level above that and says, you can't just do whatever you want with your message contracts.
Hmm.
We're going to guide you a certain way. And if you follow that, it may not be apparent right from the very beginning, but if you follow that, things will work out much better for you.
Right.
Trust us.
Yeah.
And
It's,
invariably we get this kind of pushback where people saying,
yep.
"No, but really I want to do it this way." You say, "Look, if you want to do it that way, you can drop down a layer and
Yep.
use the lower level APIs that we have of, an iMessage receiver and a thing like that.
Hmm.
But we don't recommend that you do. Work at this level. Give it a try." And invariably, what people find out is their solution is much better designed for it.
Yeah. I had similar experiences when using NHibernate, the object relational mapper. I fought NHibernate for a very long time, and I finally gave in on one particular project and said, fine, I'm just going to do it the way NHibernate wants me to do it because I'm tired of fighting it. And at the end of that project, I looked at it and said, wow, that was easy. So I can see how the same thing could happen with in Service Bus or other Service Bus implementations where you have, especially with only being able to publish an event from one place. I can see that sounds really painful to me offhand. Like, no, of course I want to be able to publish this from multiple places because I've got all these things going on. I want to audit from here. I want to do this from there. But like you said, once you have multiple logical places in your system that do that, well, now you have multiple logical places in your system that have to be changed every time the way this works changes.
Right.
And one of the ideas, especially with the single responsibility principle, is to limit the number of reasons to change something. So you don't want to have to change five different chunks of code because one logical concept changed. You want to change that one chunk of code because that one logical concept changed. So I can see a lot of potential benefit in doing that for sure.
Yeah. And there are a whole bunch of little things like that in Service Bus that
Right.
you don't realize how important they
Right.
are until you've built a system that way after doing it the old way.
Right.
And that's where I think that that's what makes a service bus,
Right.
as opposed to just an abstraction layer on top of a queuing system. It's taking
Right.
more of that architectural guidance and saying, we're not going to let you do that by default. I mean, if you really want to do that, you're going to have to drop down a layer and
Yep.
lose a whole bunch of capabilities.
Right.
But if you do it this way, it's really going to work well. And I've got to say, I've been doing this in service bus thing for probably about 8 or 9 years now,
Right.
and it's really that model has held up
Yeah.
in just so many different business domains
Yeah.
and types of companies and whatever you want to call it. That it's there is a way to break down your architecture according to those rules,
Mm-hmm.
and that when you do that, you'll kind of get this light bulb moment and say, that is so much better.
Yes. Yes. Very much so. So I want to shift gears for a moment, I guess. A few minutes ago, you mentioned systems on top of the service bus that would allow you to monitor and manage the health of the overall system that you're building. Is this where your service platform comes into play from particular software?
Yeah.
So what does that really entail? What is this service platform that you offer?
Well, without getting into too much detail, there are very basic things that you start to realize that you need
Okay.
um, around monitoring when building a message queue driven system.
Mm-hmm.
In a regular type of RPC system, the ops people are watching log files to see if exceptions are being logged,
Right.
because that's an indication that there's something wrong with the
Mm-hmm.
system. Now, in a message-driven system, because it has these kinds of retries built in, it could be that there's an exception that occurs, but the system just able to recover from that automatically.
Mm-hmm.
So then that influences not only how you log things, but also how the people will go about monitoring it.
Right, because
To
that could
say,
mask a problem.
well, part of it is, is it masking a problem or is it recovering from a transient situation in
Okay.
which the ops person doesn't actually need to do anything?
Right.
So the connection pool was maxed out, the retry logic kicked in, and then, 50 milliseconds later, it all sorted itself out.
Mm-hmm.
Do nothing, no reason to start signing or sounding the bells and saying, hey,
Yeah.
come over here, look at this.
Don't need to call the
So
on-call person at 2 a.m. for that.
exactly. So those types of things drive a very different style of monitoring of a
Right.
system. And it also leads to things like considering service level agreements. So,
Mm-hmm.
how long should a message remain in a queue and for that to be okay? And that really starts to fit into the business side of things. Well,
Mm-hmm.
how long should it be? As a developer, what do I know? The queuing system says for as long as I can keep it around forever. It's
Forever,
just
right.
using up, a megabyte of storage on disk that's
Yep.
practically free. But then, how long should we wait before we notify somebody about this?
Mm-hmm.
The next level above that is when you move from single message to message chains or message flows,
Mm-hmm.
saying if something failed, I'd really like to be able to see the chain of messages that caused that message. So it
Wow,
could be
yeah.
that this event was published as a result of a command, which was sent as a result of another event,
Right.
which was the result of, and you have this kind of really long flow.
I would
Now,
really like to be able to see that in my current system.
now in an RPC system, it's really simple because everything is synchronous and blocking.
Yep.
And if something fails, you get this big gigantic call stack that shows
Yep.
you everything. In a message-driven system, because everything's decoupled, you lose that.
Right.
So what we do, first of all, in NServiceBus is we piggyback additional headers
Mm-hmm.
that every time a message is emitted, we hold onto the conversation ID of
Mm.
the original message that comes out. So in our audit, we're able to piece together the causation flow.
Mm-hmm.
Message A caused message B, caused message C, caused message D. And then we have a UI that allows you to visualize that and
Nice.
show you how things happened, if things failed at all, the full message data that was in there, what message flowed to which endpoint. So it actually
Right.
generates like sequence diagrams for you. It's all those things that you need when debugging a
Right.
message-driven system
Right.
that, again, you don't know that you need until you're stuck peering through log files of millions of
Yep.
messages. So those are the other things that are the clear, most easily visible things that you're going to need when building a message-driven system. And of
Right.
course, there are others, but it's kind of where did the service platform in particular come from?
Mm-hmm.
It's just all of these things that people running and debugging and troubleshooting message-driven systems and versioning them run into over the lifetime of their
Right.
projects and of their systems. And I said, yep, that's a problem we should solve. That's another problem we should solve.
Yep.
Um, and just kind of doing more and more and more and more. So arguably because we've been around the longest, we've been exposed to the most
Yep.
of these kinds of problems and kind of had the biggest or the longest time to actually go around and fix those types of things.
The most experience with the number of problems that people are going to run into to be able to solve these problems that people are going to run into.
Right.
So is that service platform a commercially available product, or is that part of the open source?
In terms of licensing, everything is dual license.
Okay.
So it's open. So the code is open on GitHub. Everybody
Mm-hmm.
can come look at it and learn from it, and of course contribute patches.
Mm-hmm.
That's one of the things that clients appreciate with
Right.
open
Right.
source is that if I have a problem, I don't have to wait for the vendor to release something.
Yeah, definitely.
Uh,
It's
so being able to patch the code directly is a huge benefit. Um, but it is licensed, meaning that
okay.
um, you know there will be patches and there will be maintenance and there will be 24/7 support.
Mm-hmm.
And really you do want all of those types of things because um, you don't want to be in a situation where you're being woken up at 2 a.m. and then you have to spelunk through the NServiceBus code base
Right.
to figure out what's going on.
Yeah.
Much better to just, pick up the phone and say, I have a problem. We're like, oh, right, there's a patch release out. Just go
Okay.
use that one.
Yes.
Um, so having that there is very useful.
Nice.
And, I'd say for the vast majority of people and companies, um, their time and peace of mind
Oh
is worth so
yes.
much more than whatever licensing cost is there, and it's fairly
Absolutely.
attractively licensed compared to everything else. Of course, there are free things like mass transit, but
Sure.
you can't call up Chris at 3 a.m. and expect him to help.
No, I don't think he would like that very much. I know I wouldn't like that. So if our audience would like to go find more information about service buses in general, about NServiceBus, and about your service platform, what are the best resources to learn about these things?
I'd say about messaging patterns in general.
Mm-hmm.
There's the Enterprise Integration Patterns website and book
Right, it's a
that documents a
phenomenal
lot of
book.
them. So a great deal of information there. So if you decide to go down the path of uh, how hard could it be? I'll just do this. You'll find that book just an invaluable reference for all of the things
Tremendously
that you need to
valuable.
build,
Yes.
and some sample code on how to build that. So I think that's great. Um, in terms of the higher level architectural guidance about how to build these
Mm-hmm.
types of systems, I've been blogging for years
Right.
about that kind of stuff. So check out my blog, udidahan.com,
Mm-hmm.
and I guess we'll have a link in the show notes.
Yes, we will definitely.
And about NServiceBus and the service platform, that's particular.net.
Okay.
Very easy to find.
That's wonderful. So I do have one last question for you before we wrap up here. If you could say one thing, just one thing, as the most important point or message in this case for
Mhm.
somebody that's getting into message oriented software development and architecture, what would that one piece of advice be?
Hmm. Allow me to divide that in half.
Sure.
For the person on a project that needs to deliver a working system,
Mm-hmm.
the answer to the question, how hard can it be, is very damn hard. Do not go inventing your own wheel.
Right.
Okay? That would be my main message.
That's a good message.
Uh, for the person that's kind of in this, I want to learn, I want to figure out, I want to understand the technology. I don't actually have a specific business problem
Mm-hmm.
to solve. Then I'd say find open source implementations,
Right.
get into their code, run the samples, pick it apart, put it back together again.
Right.
That's a great time to build your own.
Yeah, yeah,
Uh,
definitely.
and you can learn a lot about queuing systems
Hmm.
that can serve you very well when when actually building a production system.
Hmm.
Once you know that, RabbitMQ, for example, uh, by default doesn't do multi-queue transactions.
Right.
So if you're reading from one queue and you're writing to another queue, then you can end up in a situation where some messages actually escape,
Hmm.
or that in the RabbitMQ client, publisher confirms is turned off by default.
Hmm.
Now, that's a very nice feature for getting high performance numbers on benchmarks,
Right.
but that can result in message loss in certain failure conditions.
Right.
So those are the kinds of things that arguably you wouldn't find out by just using things like NServiceBus, because it hides all that from you.
Right.
So when somebody says, well, why should we use RabbitMQ rather than ActiveMQ, or what are the benefits of this over that?
Hmm.
It's really hard to speak to the comparative strengths and weaknesses of technology because the abstraction layer just hides it all from you.
Right.
But again, I'd look at that as more from a research perspective, to kind of just learn about the technologies and all of the knobs and dials that are
Hmm.
down there.
Hmm.
And then potentially that can help you understand why certain decisions were made and why developers should be shielded from some of these things
Right.
when writing their code.
Right.
So that would be it's kind of a message to this audience and a message to that audience,
It's,
and the connection between them.
yeah, that's phenomenal advice. Honestly, I think I could use some of that advice myself right about now. There are certainly some times where I'm looking at my code that I'm writing in Node.js with Wascally and RabbitMQ and going, this is really damn hard. So I really appreciate you taking the time to do this interview, to be here, and to share this phenomenal knowledge and wisdom with the audience today. Thank you so much for being here.
Well, thank you, Derek. It's my pleasure.